All right, welcome everybody. This is 4.5 Quadratic Inequalities. We learned how to graph quadratic functions in the last section. So this time it's the same process. Well, we'll have a little bit of something different, but this time we are going to answer some inequality questions, like where are we above the x-axis, below the x-axis, or above and on the x-axis, or below and on the x-axis. And those questions all come from just the inequality. So quadratic inequality is of the form ax squared plus bx plus c greater than 0, less than 0, greater than or equal to 0, or less than or equal to 0, where, of course, the leading coefficient cannot be 0. Okay. So to solve a quadratic inequality, we will graph the function and determine where we are above the x-axis, or below the x-axis, or above or on the x-axis, and last one, where are we below and on the x-axis. So that's what these inequalities are asking us. So based on which inequality we're given, we should know how to answer it after finding every single component. Okay, so to solve and graph these inequalities, we will first find the vertex, then find the intercepts, graph it, and with the graph, we will determine, because for this first one, it wants to know where are we above or, where are we below or on the x-axis. Okay. And today we get to use this short way to find the vertex. No completing the square today, unless we really have to. Okay, so on the last set of notes, I marked out the short way to find the vertex. But for these ones, it's gonna help to solve these a lot faster if we just use the short way to find the vertex. So when looking for the h value of the vertex, we will put the b value of the quadratic inequality over 2 times the a value of the quadratic inequality. So there's b and there's a, right? If you know those, you're fine. To find the k value, we're going to take whatever we found for h and plug it in for x into the quadratic inequality, and this will give us the k value. All right. So let's get started. Okay. Fit it down. So A, we're going to find the vertex. So first thing we want to find is h. So let's say vertex, and we're going to look for h. H is negative b over 2a. Negative b over 2a. So negative b over 2a. And from the quadratic inequality given, a is 1 and b is negative 4. So you get negative 1 times negative 4 over 2 times 1. This will give me 4 over 2, which gives me 2. There's the h value for the vertex. Now we want to find the k value. So to find k, we just take whatever the h value we just found, which is 2, and plug it into the quadratic inequality we were given. So we'll have 2 squared minus 4 times 2 minus 12. Simplify. 4 minus 8 minus 12, and that's negative 4 minus 12, so we get negative 16. This means our vertex is at 2, negative 16. Okay, vertex is done. And next is find the X and Y intercepts. So B. We'll go for the X-intercept, where you let f of x equal 0. And we'll take the function from above, x squared minus 4x minus 12, and set it equal to 0. X squared minus 4x minus 12 equal to 0, okay? And hopefully it's factorable. If it's not, then we have some more work to do, which involves completing the square. And this one's definitely factorable. It's going to be x minus 6 and x plus 2 equal to 0. Squared, 2 minus 6, negative 4, negative 6 and 2 is negative 12. And we get x equals 6 and x equals negative 2, which creates our x-intercepts of 6, 0, negative 2, 0. And then y-intercept, it's where you let x equal 0. So you'll have f of 0 and plug it into the function given. And the function is written right next to it on the x-intercept. So if I plugged in 0, this would be 0, that would be 0, and we would be left with negative 12. Which means our y-intercept is at 0, negative 12. Okay. Step C is to graph it based on vertex, intercepts, and yeah. I was going to say y-intercepts, but intercepts covers all of that. Okay, so let's graph it. And let's do this again. And 2, negative 16. Oh, all right, we gotta adjust our x-axis, our y-axis. So we'll just go by 2's. 2, 4, 6, 8, 10, 12, 14, 16. Negative, 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 negative. And I'll do the same above. 2, 4, 6, 8, 10, 12. I think that's as high as we go. Okay. Now plotting the points given. First is a vertex. 2, negative 16, which is going to be right there. There's my vertex. And then I'll plot my x-intercepts, which are at 6, 0, and negative 2, 0. And then my y-intercept is at negative 12. All right, so remember 3 points to make a parabola, the vertex being the main one, and a point to the left, and a point to the right of the vertex. We have all of it, so let's go ahead and connect. All right. And now, we do all of this to answer one simple question, which was asked in the very beginning. Where is this function less than or equal to 0? Meaning, where is this function below or on the x-axis? So let me write that in there. So f of x less than or equal to 0. We'll answer that right here. So we're looking for intervals here. Where are we below the x-axis and on the x-axis? What x values? All right, well here is negative infinity and there's infinity. If you look from negative infinity to this point at -2, the function is above. We don't want above, we want below. So then we see that at -2, we are actually on the x-axis. So the first part of our answer is going to be, get rid of that, bracket -2. And then from -2 to that x-intercept of 6, we see that the graph is below. So that's what we're looking for. From -2 to 6, we are below. And then also at 6, we are exactly on the x-axis, because that's what we're looking for. On what x intervals are we below and on the x-axis? And that's going to be from -2 to 6 included. That's it. That's all we have to do. Because then from 6 to infinity, we're back above. Okay. That's it. That's all we have to do. No completing the square needed yet, right? So this is, step A is definitely the fastest way to find the vertex. But completing the square is something you definitely need to know how to do as well. So I show you both methods. Now you know there's 2 methods to find a vertex. All right, good times. Vertex, intercepts, graph, determine. All right, good. All right, let's do it again. X squared minus 4x greater than 0. Okay. So start with A. Oops. Find the vertex, and here h is -b over 2a, and our b value here is -4, and our a value is 1. So again, we get -1 times -4 over 2 times 1. 4 over 2, we get 2. Okay, and then k, oops, stop it, is f of the h value we just found, which is 2, and plug it into the function above for every x. 2 squared minus 4 times 2. And hey, look at that. That's 4 minus 8, which is -4. So our vertex is 2, -4. Okay, next is intercepts. X squared minus 4x. So B. So x squared minus 4x equal to 0. So set the function equal to 0, solve for x, factor out an x, and solve for x. You have these two terms, so you get x equals 0 and x equals 4. There it is. There's the x-intercept, 0, 0, 4, 0. And then y-intercept, x equals 0, so f of 0. And once again, I wrote the function over here already. So if you plug in 0, this becomes 0, that becomes 0. So f of 0 is 0. Okay. All right, no need to adjust intervals this time, which is great. Our numbers are small enough to fit on the graph. So vertex is 2, negative 4. So 2, 1, 2, 3, 4. So 2, negative 4, there's my vertex. Then my x-intercepts are at 0, 0, and then 4, 0. And my y-intercept is 0, 0, which is there already. So our 3 points. Vertex, point to the left, point to the right. So now connect. Fun colors. There it is. And now, let's go ahead and answer. Do all this work to answer that one simple question. Where are we greater than 0? Where are my y values greater than 0? Meaning, where are we above the x-axis? F of x greater than 0. Okay, let's look at it. I'll label things again. This is 0 and 4. Okay. And greater than 0. F of x greater than 0. So where are we above? What x intervals are my y values above the x-axis? So looking at your graph, there's negative infinity. As you approach from the left side, we see that from negative infinity to 0, this graph is above the x-axis. So that's our first interval. Union, because then we keep looking, and as we keep going, from 0 to 4, we are below the x-axis. We want to know where we are above. So we don't, after 0 to 4, we go from 4 to infinity, and look at the graph. Once again, we are above the x-axis. So this means that we'll have union 4 to infinity. Now notice the difference with this answer from the last answer. There's no brackets. And that all depends on the inequality, right? Greater than or less than, get parentheses. Greater than or equal to, less than or equal to, get brackets. There it is. Once again, all that information to answer that simple question. Where are we above? or below. Okay, last one of these. So maybe last one. So find the vertex again, but before we begin, we must rearrange. This is not in the proper form. So all we have to do is take everything from the right side and just move it to the left. So this becomes 2x squared minus x minus 10 less than 0. So that's a new one we're working with. Okay. So find the vertex. H is negative b over 2a. My b value here is negative 1. You get negative times negative 1 over 2 times my a value there of 2, which gives me 1/4. There's the h value. Okay, and now we want the k value. So for k, we get f of 1/4 and plug it into the function above. So 2 times 1/4 squared minus 1/4 minus 10. All right. 2 times 1 over 16 minus 1/4 minus 10, which then gives me 1/8 minus 1/4 minus 10. And then I want to put all these together. So I'm going to put 10 over 1 and get a common denominator of 8. So this will be multiplied by 8 over 8, and this one will be multiplied by 2 over 2. And we get 1/8 minus 2/8 minus 88. So 1 minus 2 is negative 1/8, and negative 1 minus 80 gives me and there's our vertex. Which would probably be wise to put in decimal form so we know what we're graphing. So, and 81 over 8, what is that? 10 point, let's see, 10.125. Negative. Okay. There's vertex. Next is X-Intercepts. Let's hope those are easy. And our function was 2x squared minus x minus 10. Well, there's one thing we can hope for is this factorable? Oh boy. So for this one, well, first one's easy. Factors of 2 are just 1 and 2. So I'll do 2x minus a number. and x plus a number. Now, the factors of 10 are 1 and 10 and 2 and 5. So with that being said, I'll probably put 5 here and 2 there. So let's check our work. That's 2x squared, that's 4x, negative 5x, and negative 10. So 4x minus 5x gives me the negative x in the middle. Hey, factorable, good. Which means set them equal to 0, and we'll get x equals 5 halves, and x equals negative 2. And there's our X-intercepts. Next is your Y-intercept, where you let x equal 0. And f of 0, once again, I wrote the function over here to the left just to make it faster. If you plug in 0 for every x, you get 0, 0, and you're left with negative 10. All right, so let's graph. All right, so for this one, let's see, let's look at my vertex. 0.25 and negative 10.125. I'm gonna leave my y values alone because we can just sneak 10.125 in there. But for my x values, I have a 0.25 and I have a 2.5. So maybe we can go by quarters. Let's see. Let me see. Then I have negative 2 on the other side too. So I can say 0, half, not half, quarter, half, 3/4, and 1. And then that'd be 1/4, half, 3/4, 2. And then here would be 2.5. It's pushing it, but we could always guesstimate it too. But I think I'm going to make this one perfect because we're going to need to actually state the right intervals. Okay, so yeah, so fill that in, and then over here, same thing, negative 1/4, negative 1/2, 3/4, there'd be negative 1, and then 1, 2, 3, 4, negative 2. Okay, so that went by quarters, which means let's now graph this. All right, I'll plot my vertex, which is at 1/4 and negative 10. So that's basically negative 10.13, which is, I'm gonna put right down there. There's my vertex. And then I'll plot my Y-intercept, which I see first right there is negative 10. So gotta go there. And then my X-intercepts are at 2.5, which is here. That's 5 halves, right? And then negative 2, which is here. Yeah, look at that. Not bad. And then all right. So there is our parabola. We didn't have to adjust the intervals, but I wanted to just so we can see, so we can answer the final question. which is where are my y values less than 0? So again, where are we below the x-axis? So f of x less than 0. So where are we below the x-axis? And it's basically right there, right in front of us, from -2 to 2.5. This whole graph is below the x-axis. So we just say -2 to 2.5, and that's it. Done. So that's how you will handle these quadratic inequalities. Find the vertex, find the intercepts, graph it, and then answer the question of where are you above the x-axis, below the x-axis, above or on, and below or on the x-axis. That's it. Not too many steps involved, right? But knowing the graph gives you the better visual of where it's at. Okay. Last question is the domain. What is the domain of this given function? X squared minus 16. Okay. So first thing we should note is that this is a square root function. So to find the domain of any square root function, so to find the domain, you always take whatever's inside the house and set it greater than or equal to 0. Okay. And look at what we have. We end up with a quadratic inequality. Okay. So on the past two examples, I showed you how to graph them and solve them. There's another way to actually solve these as well. So let's go over this method, because maybe this one might work out better for you. So to solve for the domain of this function, and it's a quadratic inequality now, take the function and set it equal to 0. And solve for x. If you move the 16 over, we get x squared equals 16, and then square root both sides, and we get x equals plus or minus 4. Okay, so now, what do we do with that information? Well, what we do with that information is now we make something called a sign chart. A sign chart. And sign charts are number lines. So for my number line, it's going to go from -infinity to infinity. And on my number line, I'm going to plot the x values we just found. -4 and 4. And now, what we're going to do next is pick test numbers on my sign chart and test them into the original function. So when we do that, let me write the intervals first. So when I say intervals, we have 1 interval, 2 intervals, 3 intervals. So the first interval is from -infinity to -4. The second interval is from -4 to 4. And the third interval is from 4 to infinity. So when I say pick test numbers, you will pick test numbers in between these intervals. So test numbers. So for the first interval, from -infinity to -4, I want to pick a test number in between -infinity and -4 and keep it really simple. A number in between -infinity and -4 is going to be -5. And then I want to pick a test number from my second interval, -4 to 4. Give me a number from -4 to 4, between there. And the easiest answer is 0. And then I want a number from 4 to infinity. Means again, keep it simple, just say 5. If you pick 5, 500, 5,000, 5 million, as long as it's in that interval, we're gonna get the same result. But like I say, keep it easy and choose 5. Okay, so now we're gonna take all these numbers and test them into the original function. So I'll get f of -5, which gives me the square root of -5 squared minus 16. This will give me the square root of 25 minus 16, which gives me the square root of 9. Now, I don't care about the answer. I'm just looking at the sign of the result. You get the square root of 9. Can you take the square root of 9? And that answer is yes. The square root of 9 is 3. So what this tells us is that, looking at the sign chart, no matter what number you pick from -infinity to -4, you will always get an answer. So this means that the interval from -infinity to -4 checks out. Okay. Now let's test 0, and you'll see how this all comes together. F of 0 gives me 0 squared minus 16, which gives me the square root of -16. See it now? Can you take the square root of -16? And the answer is no. Technically, yes. If you do, you'll get what type of numbers? You'll get imaginary numbers. So when dealing with a real function, we can't have the results of imaginary numbers, which means that this isn't going to work out, which means that any number between -4 and 4 will not work. Okay. And then test the last number, and you get 5 squared minus 16, which gives you 25 minus 16, which gives you the square root of 9, which again checks out. Okay. Which means that if you choose any number from 4 to infinity, you're going to get a result that you can take the square root of, which means this interval works. All right. Now, let's put it all together for the final answer of what it was asking us. So, we were being asked, where are we greater than or equal to 0? So, and once again, this means where are we above the x-axis and where are we on the x-axis? All right, well, if these y values are positive that we got from plugging in the test numbers, This means if you're positive, you are above the x-axis, which means that we start with negative infinity, and we stop at negative 4. Now, negative 4 is an x-intercept also, which means it is on the x-axis. So we'd have negative infinity, negative 4, bracket, union, and then we know no number will work from negative 4 to 4, which means we go to the last interval, we start again at 4 because 4 is on the x-axis, and head towards infinity. That's it. And that is another way to solve quadratic inequalities. If you did not like that method, then stick with the methods we were using earlier. Graph it, vertex, intercepts, Y-intercept, and answer the question. But I'm just showing you this is another way to do it, and I'm introducing a sign chart, which we will be using in the upcoming chapters. So, introduce it to you now, just so you get a taste of it. Okay, well, that is it for quadratic inequalities, which gets us set up for our first exam. Woo! All right, so see you after the exam, right?